This video goes through congruent triangles. Now, two triangles are congruent if they are identical, and that means identical in every respect except for position. Okay, so what that means is if one triangle was cut out with scissors and placed on top of the other, they would match each other perfectly. So these two examples here, these triangles are congruent. We write triangle ABC is congruent to triangle X, Y, Z, and those three horizontal lines means is congruent to. Now also note, and this is something that we often forget, including myself, that when writing the congruency statement, we label the vertices in the same order as their corresponding positions. So when I wrote that congruence statement, I went from A, which was my alpha, B, which is my beta, and C, which was my theta, and then I started the same place on my X. So with alpha, then beta, then theta. So X, Y, Z. So they're written in the same order. Now we have 4 tests for congruency. The first one is side, side, side. That means all corresponding sides are equal in length. Our second one is SAS, or side, angle, side. And that means our two sides and the included angle are equal. Now included means it's in between our two sides. So you can see that angle is in between is in between the two sides that we know are equal. Okay. AAS, two angles and a pair of corresponding sides are equal. And finally, RHS, which means we have our hypotenuse, we have our right angle, and then we have one other side. Okay? So, right angle, hypotenuse, side. Okay, so let's look at some examples. Now, I recommend when doing these, write the conditions at the top of your page so you remember what you're looking for. First one, part A. If I look at these two triangles, and now I'm trying to think SSS, SAS, AAS, RHS. I can see two sides and I can see an angle. The angle is not an included angle, but it is a right angle. And one of the sides is our hypotenuse. So straight off, I'm thinking to myself, RHS. So have that goal. Now go through to work it out and state why they are congruent. I know that I might move that over a bit so I don't run out of room. BC equals KM, and they're the hypotenuse. Okay, I know that AB equals LM, and I know that angle BAC equals angle MLK, which are 90 degrees. So I have, and I also know that AB equals LM, and they are corresponding. So they're in the same position on the two triangles. That's important as well. So if I rotated ABC, I could end up with it being in the same position as the triangle KLM. So now I know that triangle ABC, now I started at the right angle. So when I write my next triangle, I have to start at the right angle and go up. So is congruent to triangle LMK, and the reason for it is RHS. Now let's look at the next one. Straight off, I'm seeing three sides. Okay, if I rotate it around, they'd be on top of each other, so I'm going for SSS. So AC equals PQ, BC equals RQ, and AB equals PR. Okay, so therefore, nice and easy one, Now we have to get them in the same order. I'm going to start at A and I'm going to go up with my single line. So that means I have to start with P and go up that way. So triangle A, it's a really dodgy triangle. Triangle ACB is congruent to triangle PQR, and my reason, side, side, side. The next one, I've got two angles and I've got a side. So I'm hoping for AAS as long as everything is in the corresponding position. So that means that if I cut one out and put on the other, it would work. And I can see that that would work by rotating and flipping ABC. So now I just go through and I go angle BAC equals angle, so I've gone my alpha FDE, angle, now do theta, BCA equals angle FED, and then AC equals DE. So triangle, now I have to go in the same order. I'll start at A and go to the side that I've got. So triangle ACB is congruent to triangle. So I start with my alpha and go along the side. DEF, and my reasoning is angle, angle, side. Final one. Okay, so I've got my alpha, I've got a theta, so they match, and then I have a side, and the side on this one is up from theta, but the side on the second triangle is actually up from alpha. These are not congruent triangles. Okay, because it's not the corresponding sides that are equal. So I just write corresponding sides are not equal. Now let's do a couple of proofs. Again, I've written my conditions at the top, so I know what I'm looking at. First one is prove that triangle ABC and triangle EDC are congruent. Now, although I have a right angle in both, I don't have the hypotenuse. So my hypotenuse on the two triangles would be those, and I don't have them. Okay, but I do have two sides and the included angle, meaning the angles in the middle. So I'm looking in this case to prove SAS. So go through AB equals DE, BC equals CD, and angle AB, angle ABC equals angle EDC, which is 90 degrees. Okay, so just because you see a 90 degrees, don't fall for it's going to be RHS. Now start with the same thing. I usually start with the angle that I'm given, so the right angle. So triangle B, I'm going to go up to A and across to C, is congruent to triangle DEC. Now note, it doesn't matter which order you put them in, just do the corresponding vertices. And my reasoning is SAS. In the final one, prove that MNO and PQO are congruent, and hence find the value of the given variable. Now, my key here in this one is that I have these parallel lines. Okay, so I have a set of parallel lines. So I'm going to be looking for my angle properties. So what I mean by that is if I look for alternate angles, so my Z, that means that this angle here has to equal that angle there. Okay. Similarly, if I go the Z going this way, that means that this angle here has to equal that angle there. And finally, because of vertically opposite angles, that angle has to equal that angle because of my X. And I'll show that. So x. Okay, so that means that I have 3 angles are the same. Now that's not enough, because if I have 3 angles the same, I know they're similar. Okay, but I have all my angles are the same, so now I have to have a set of corresponding sides the same. So I'm hoping to find, I'm hoping to prove AAS, and when I look at it, my 2 triangles, I have a 7 here. I'll make that a bit colour that you can see. I have a 7 here and I have a 7 there. And if you rotated that second triangle, that PQO, in an anti-clockwise direction, you would be able to sit it on top of the other triangle and the angles match. So I know they're congruent. I now just have to write out what I've got. So I've got that MO equals PO, which is 7 centimeters. Now go through my angles. It doesn't matter which ones you use. You just have to have 2 angles. So I'm going to go the corresponding, because then I say they're the same rule. NMO equals angle, so my red one, QPO, angle MNO equals angle OQP, and the reason for both of these is they're corresponding angles. Oops, no they're not, they're alternate angles. Or the Z rule, whichever way you want to put that. So therefore, triangle, now I'm going to go red, blue, middle. So triangle MNO is congruent to triangle red, P, blue, Q, O, and the reasoning is AAS. Now there's a final part. Find the value of the given variable. So that's my x over here. So it corresponds to the 6.5, because it's the side where the red circle and the star is. So x equals 6.5 centimeters, and that's because MN equals PQ. And you're done.